Good evening, everyone. Welcome to Café Scientifique today again. Like last week, my name is still Magdalena Bazalova-Carter. I'm from the Department of Physics and Astronomy at UVic, and I'll be moderating today's Café Scientifique about the Victoria Hand Project. So I'm very excited about this topic, and I would like to welcome Kelly Knights and Michael Peirone. It's obvious who's who, I hope. And they will both tell us about the great work that they're doing with their organization. And just a brief introduction on Kelly and Mike. They're both the graduates from our biomedical engineering program at UVic. And they kind of started working with the Victoria Hand Project very early on in 2014 and 15 after they graduated. And Mike is currently the COO? CEO, sorry.
There's a change in leadership recently. So.
Okay, not my fault that I didn't know that. And Kelly is, I forget.
Biomedical systems designer, lots of hats.
Kelly wears lots of hats. So I've got something to tell you. So when I was asking Victoria Hand Project to come here and tell us about their work, we put together their bios. It's all online, so if you want to know more about Kelly and Michael, you're most welcome to read that online. And they came back to me later on. They're like, well, you know, in the advertisement it says Dr. Kelly Knights and Dr. Michael Peirone, but we are not doctors. I'm like, no, that's okay. Take it when you can. People call you doctors. So that's super exciting. It's always nice when people do that, even to my students. People sometimes do that to me too. What I think is very nice about also Mike and Kelly is that they do like rock climbing and outdoors activities, and that's probably one of the reasons why they're still in Victoria, apart from the Victoria Hand Project, and it's probably the reason why lots of us are in Victoria, including myself. So with that, I would like to give you the floor and tell us all about your hand prosthetics.
All right, hello everyone. Thank you so much for coming out to see us present tonight. Thanks for coming to Café Scientifique. As was mentioned, my name is Kelly Knights and this is Michael Peirone. And we're here today to talk to you about the Victoria Hand Project, which is a Canadian charity that was spun out of a research lab here at the University of Victoria. And VHP, or Victoria Hand Project, we make functional 3D printed upper limb prosthetic arms for amputees in need all over the world. So I have been working with the Victoria Hand Project full-time since May 2020, but I have been with the project many years before that. I volunteered a lot during my undergraduate degree, and I did a co-op term. And Mike has been with the project since the very beginning, before it was even a company, back when it was just research. And so he's been with the project in many different forms. He was a volunteer, a student co-op, a chief operating officer, and now CEO. So we're really excited to tell you a little bit more about the project. So today we're going to be talking a bit about the history of the Victoria Hand Project and how it started. Then we're going to go on and do a little deep dive into 3D printing, different types of 3D printing. And lastly, we're going to share some patient stories about people around the world who we have fit with our hand. So I'm going to start off a bit with why the Victoria Hand Project exists. So in a 2009 publication conducted by the World Health Organization, it was estimated that there are 2.4 million upper limb amputees living in developing countries who do not have access at all to a prosthetic device. So this reveals a clear need for prosthetic arms, especially in developing countries and places where healthcare systems may not have the necessary support from their government. A lot of the places we work, they simply don't have the infrastructure to make really complex prosthetic devices. They may not have, there may be a lack of trained healthcare professionals to fit amputees with the prosthetic devices. And of course, the biggest barrier to care is just the cost of the prosthetic devices. Almost all prosthetic arms are thousands of dollars, which is expensive. A lot of people can't afford that, especially if it's not subsidized or covered at all. So as a result, there's a lot of amputees who choose to go without a prosthetic arm, which can be really difficult, especially in places where limb loss is very stigmatized. And of course, on top of the social aspect, there's a lot of things that are really tricky to do when you're missing one or both of your arms, lots of things that able-bodied folks like myself take for granted, such as eating or dressing yourself, using public transit. All of these things become much more difficult with a major physical disability. So the Victoria Hand Project is born out of this need to help these people, and having a functional prosthetic device can be a really important tool to regaining independence. So what started as a research project to test the feasibility of 3D printed prosthetics quickly spun into a nonprofit and later a charity. So I'm gonna back up a bit to give a little bit of context. Back in the 1990s, Dr. Nikolai Dechev, who's now an associate professor here at the University of Victoria, developed a prosthetic hand for his master's degree at the time at the University of Toronto. So this hand was really revolutionary for a lot of reasons. It had what was known as adaptive grasp, which meant the fingers could conform around different objects. It also had a movable thumb, which meant the hand could do a variety of different pinches. So this hand was pretty breakthrough at the time, but it was made using traditional manufacturing techniques, and it was really expensive. So it was a master's project, and then it kind of sat on a shelf for many, many years. And as the years went on, 3D printing became a lot more accessible for a lot of people. What started as what used to be really expensive and only available to kind of top researchers now is available for hobbyists, and people can just have 3D printers in their house now. So then later, a student had approached Dr. Dechev and proposed, why don't we try to remake this hand out of 3D printed parts? So funded by Grand Challenges Canada, a really early Victoria Hand Project group traveled down to Guatemala with their 3D printed hand prototype, and they got together a small research group to try out the hand for a couple weeks. And not only did people in this research group really find the hand very good, they really enjoyed the hand, a lot of them asked to keep the hand after the research trials had been done. A lot of them either had never had a prosthetic arm before and they found it useful, or they had only had a traditional hook prosthetic and they wanted one that looked a little more similar to an anatomically correct hand. So this, along with kind of a little bit of research into the need, really sparked the idea to start off as a company to provide these hands to people in need around the world. So today we work in 8 different countries around the world, and how we work is, it's a little more complicated than just us providing the hands to amputees. So what we'll do is one of our team members will travel to the countries that we work in. They will meet with medical professionals there. So all of our partner teams consist of a certified prosthetist, which is someone who's gone to school to fit prosthetic devices on an amputee. We will also find some tech-savvy folk, and we will train them how to use the 3D printers. We'll train them how to make the hand. And then our partners will be very self-sufficient in a way. So after we're done training them, they are able to meet amputees, they're able to fit them with the hand, they're able to do everything. So we supply the 3D printer, we supply all of the design parts, we provide the materials, but our partners are the ones who are on the ground in country, and they are printing out the parts, they're assembling the hands. The clinicians are meeting with patients and they're taking measurements, they're taking scans, cutting out a custom limb socket, putting it all together and getting the hands to them. So what we do here in Canada is a lot more of the back end kind of machine that runs the Victoria Hand Project. We're doing a lot of testing, we're doing a lot of updates, we're trying to make the hand more usable and more useful for the people that are using it everywhere. We also do all the coordination with our partners. We do a lot of making sure patients can get to them when we get emails. So it's a big collaboration between us and our partners in the 8 countries we work in around the world. And all of this is really made possible with 3D printing, and it's an incredible way of making custom on-demand parts anywhere that we can put a 3D printer. So I'm gonna pass the mic off to Mike to talk a little bit more about 3D printing.
Sorry, I'm all wrapped up here. So you might be wondering why we actually use 3D printing to produce these prosthetic devices. That's primarily because 3D printing has a lot of advantages over traditional manufacturing techniques for making prosthetic arms and legs. So the conventional way of making prosthetics is very burdensome, it's expensive, and it requires highly skilled professionals to make the designs. In many of the countries where we're working, there aren't always a lot of these skilled professionals to make the prosthetic devices. This means that there's a big backlog of patients that are waiting for devices. So what we want to do is we want to create tools that the clinicians can use to free up their time so they can help more patients. There's also some other advantages to using 3D printing. It allows us to make very complex objects. Here I have a wrist ball which goes on the prosthetic hand. We can pass this around after so you can all see. But this is a spherical end with some divots in it, and the divots are for the wrist ball. When it closes, the rubber will latch into the divots. And making this with traditional manufacturing techniques would be close to impossible. It would be very expensive if you could do it. And that's just because of the geometry. It's a spherical surface, if anyone has experience with traditional manufacturing, you might see that it's very difficult to do. But with 3D printing, what we're able to do is we can design this on the computer, put it on the 3D printer, and then print it in just a few hours. So it's actually very easy and straightforward to do. Do you want to pass it to someone? Also with 3D printing, we're able to do on-site manufacturing very easily. So what we do, as Kelly mentioned, is we will put the 3D printers in the developing countries. So then when somebody approaches the clinic, they can quickly and easily get a custom prosthetic arm. But with conventional prosthetic devices, if somebody wants a prosthetic arm, they will usually need to order it from another country, which is very expensive or very time consuming. But with 3D printing, somebody can just walk into the clinic, they can have a custom device made, get in much less time and for much less money. Also, with the on-site manufacturing, if a component breaks, like say one of the finger links breaks, rather than needing to order a custom part or sending the arm off to another country, they can just 3D print a new part right there in the country and it's ready in just a few hours. Also, 3D printing allows us to do mass customization. So with 3D printing and combination of 3D scanning, we can make custom forearm sockets or upper arm sockets. And I'll be highlighting this in a little bit as well. Also, 3D printing also allows for lower cost manufacturing. Conventional prosthetic devices are very expensive. The manufacturing techniques are very advanced. They require highly skilled people. But with 3D printing, the 3D printer will do the hard work, leaving the, rather than the clinician needing to do it, which helps save money. So I just want to talk a little bit about 3D printing, since some people might not be very familiar with it. It's a buzzword which everyone hears. So I'll just highlight some of the different 3D printing techniques, talk a little bit about what we use and why we use it. So the Victoria Hand Project uses a manufacturing technique called fused deposition modeling, or FDM printing. So in this type of 3D printing, there's a spool of material, usually a plastic material, and it will be fed through a motor into a hot end, and it will begin to lay down the material layer by layer. And the parts that we're passing around, you can actually see like the layers of the part, so you can see how it was oriented, how it was built. And by using this, it's very easy to create very complex objects. Also, we use a material called polylactic acid, or PLA. So this type of material is derived from starches such as beetroot or corn. And this allows it to be very biocompatible with someone. So there are other types of materials which are very common on the market, but they're sort of petroleum-derived products, which means it's not something you'd want to have against your skin for long periods of time. There's the forearm socket, which Kelly held up, and I'll touch on briefly. And that's right up against the skin of the remnant limb. You don't want something that's a little toxic against the skin for long periods of time. So that's why we use this biocompatible material. There's another type of 3D printing, which we started using at the beginning of the Victoria Hand Project, called SLA, or stereolithography. So this type of 3D printing has a vat of photopolymer resin, and there is a UV light which will shine, and it can be reflected off the mirror, and the mirror can reflect the light to the exact area that it needs to go, and it will start to cure this photopolymer resin, and it can build up a part layer by layer. And you can get very accurate and high resolution parts using this type of 3D printing. The only problem is, though, that you require a very clean environment to do it. We actually tried this type of 3D printing in some of our partner clinics earlier on, just because it's produces very high quality parts. There's some groups that are using it even for dental. But the only problem was that the workshops they're working in, there's lots of dust, there's lots of materials lying around, and it made it so when the light was trying to reflect off the mirror, it would scatter and the part would fail. So it's just, you need a very clean environment for doing this. And the work that we're doing in many of these countries, we don't always have that environment. There's another type of 3D printing called SLS, selective laser sintering, and another one that's somewhat derivative of that called direct metal laser sintering. So in this type of 3D printing, there's a bed of a powder, usually a nylon or a metal powder, and a high power laser will melt some of this powder and it will solidify, and they can begin building up a part layer by layer. The only problem with this type of 3D printing, it is very expensive. I have a friend that works for a rocket company who had one of these 3D printers that printed in titanium, and the printer was $750,000 US. So a little bit out of reach for a charity like ourselves. But then there's another really great type of 3D printing coming out. It's called multi-jet fusion by HP, Hewlett Packard, who many of you might know. They make many of the computers and laptops. This type of 3D printing uses a inkjet, and it will lay down the material, and then a heater will solidify it. And these produce some of the highest quality parts. They're some of the strongest, but unfortunately, it's very expensive as well. So this is one of the reasons that we are using fused deposition modeling, FDM printing, which I first mentioned. It's just very low cost, very easy to use. And some people ask us why we don't use injection molding. So for people who aren't familiar with injection molding, there is a mold, which is usually 2 or 3 parts, and the 2 parts of the mold, or multi-part mold, will come together, and the interior cavity is the shape that you want to make. Many of the things you have at home are probably injection molded plastic. You can tell because there's a seam along one of the areas. And this works by the parts of the mold coming together, and a heated liquid plastic will be forced in. Then this cools and solidifies, and the mold will open, drop out the part, will close, force the material in again, and you can get a high quantity of these parts in a short amount of time. But the only problem is it's very expensive. So we estimate that it would be around a few $1,000s for each part that's in the, to make each part. And there's around 20 parts in the Victoria hand, meaning that it would be over $100,000 just to create the molds, to create the hand parts. And the hand parts are also very complex, so we don't know if all of them can be made this way. And the problem is, if you change the design at all, you have to recut the mold again. So we're always doing iterations on the designs. We want to make them better. But if we did injection molding, we'd kind of be locked into one design. Another thing with injection molding is we can't easily make the custom forearm sockets. So, thank you. So the forearm socket is customized to each user. It has the correct length, the correct circumference. If you look around, everyone has different sizes of arms. Everyone has a different size length, different circumference around it. And then an amputee will most likely have a different residual limb length. So this isn't something that can be made with traditional manufacturing techniques. This has to be made by 3D printing or other prosthetic techniques, but it's not something that can be made with injection molding. So the way that we create these sockets is we have something called a plaster impression. So the plaster impression is a exact replica of the person's limb. And in the clinics, what they'll do is they will use a technique called photogrammetry. So they'll take 60 to 80 photos completely around the device, or the object, and then they will put that in the software, and the software on the computer will rebuild this, and you'll get this exact shape on the computer. Then we are able to take a pre-sized socket, which is the correct, circumference, width, length, to match someone's unaffected limb. And then in the software, we can put the 3D scan into the socket. Then we cut out the shape of the 3D scan, the shape of the limb, and then we're left with a socket with a cavity the exact same shape as someone's limb. So this creates a very comfortable fit. It allows it to look much more natural on the patient. And then the partners can put this on the 3D printer. It will be done in a few hours. This means that somebody can approach the clinic for a prosthetic arm. They will be measured. They will have their plaster impression taken. The clinicians will make the custom socket with 3D scanning and on the computer. Then they can put it on the 3D printer, print it off in a few hours, and somebody can get an arm the next day. So there's a number of hand types that can go on this type of socket, and I'll let Kelly talk about these.
So the Victoria Hand is a fully body-powered device. So we don't have any electronic components at all in any of the functional hands that we offer. So how it works is using a harnessing system that kind of uses movement in other areas of the person's body to open and close the hand. How it works is a person will slip on a harnessing system. You can see Mike demonstrating this. This is what we call the able body brace. It lets us use the hand when, of course, we have another arm. So the person will slip on the harness almost like a backpack and get it over their shoulders. And then by shrugging their shoulders or reaching forward, a cable that runs from the inside of the hand across the arm and into the harnessing system is pulled tight, and the hand is actuated. And in the case of this hand, the hand closes when Mike shrugs his shoulders. This is what we call our voluntary close hand. When the user is relaxed, the hand is open, and then when they shrug their shoulders or reach forward, the hand closes into a pinch. So this can be really nice and pretty intuitive because the amount of pressure that you put in your shoulder shrug can be translated into the pinch force to pick different things up. It's our most popular hand. Almost all of the people that we have fit with a hand are fit with our voluntary close hand. And it also has a feature called the back lock. So you can see on the palm of the hand here, if we press this button, Mike can close the hand as per normal, and it clicks shut, and it'll stay shut. So this is really useful if you wanted to carry a bag or hold on to an object for a long period of time. And then to unengage the back lock, you would just press the button on the palm again, and it's back to opening and closing as per normal. On the other side of things, kind of the opposite of that, we also offer a voluntary open hand. So this hand is closed by default, and when the user shrugs their shoulders or reaches forward, the hand opens up, and then when they relax, it'll snap shut again. This hand is really preferred by people who have used a traditional hook in the past because it works the exact same way. Most people that receive the split hook prosthetic device, it's a hook, and you shrug your shoulders, and it'll open, and then you relax, and it'll shut to hold things. We can adjust the strength a little bit on the voluntary open. While we're building the hand, we can add more or less springs that will change how tightly it grasps. So if somebody wanted a hand that really had a strong grasp, we could put four springs in there. And if they wanted something that was a little more gentle, we could lessen it down to 2. But once the hand is assembled, it's kind of set in its ways. And both of these hands have a lot of features in common as well. So both of them have that movable thumb that I'd mentioned before, which lets you close the hand in a variety of different pinches. You can do the precision pinch, kind of the key pinch. You can move the thumb off to the side if you want to carry a bag without the thumb needed. And for things that do require that really precision small pinch, we cast the fingertips in silicone. So we'll take the 3D printed fingertip parts and we will dip them into a mold. We'll let it set for a day. We'll take it out, and then we have these kind of grippy silicone tips that just make it a little bit easier to pick up smaller things. Both hands have the adaptive grasp, which I mentioned earlier as well. So how most prosthetics today work is all 4 of the fingers will move at the same time. It's almost kind of like a crab-like pinch. How the Victoria Hand works is while all of the fingers do close at the same time, they're all a little bit semi-independent. So they're able to kind of conform around different objects to get a better grip on especially round or irregularly shaped objects, just a little more surface area to hold on to that. And the last feature that I would say the two of them have in common, and one that's really important, is the ball and socket wrist that we have. So as you can see, we have the hand here, and we can open up the wrist latch. We can bend the hand in any orientation. You can snap it shut, and the hand will still open and close in any direction that it's pointed in. So this feature is especially important because a lot of amputees, when they have their arm amputated, they really lose the ability to rotate their arm like this anymore. So this action, which is called supination and pronation, it results from the radius bone in your arm translating over top of the ulnar bone in your arm. And so if part of your arm is missing, this translation motion can't happen anymore. So as a result, many people, when they're using different prosthetic devices, have to really make up for that lack of motion with their entire body because you aren't able to rotate. So with the 360-degree wrist, it's a lot easier to kind of sit naturally, and you can use the wrist to kind of have an extreme motion to make up for that lack of arm rotation. It makes it a lot easier to grab things from different directions and orientations. So even though we might lock it in a position that isn't something you would probably do with your anatomical hand, it's really, really helpful when you're trying to pick things up with a prosthetic hand. And the last type of functional prosthetic hand we offer it's just kind of a smaller version of the voluntary close. It's pretty new for us. We originally called it the child's hand because we were trying to fit some children who found this hand was a little bit too big. But it's also kind of a great option just for some women or some people with a smaller frame. It works the same way. The person would shrug their shoulders and it'll close, but it's been great because it's allowed us to help a lot more people who wanted kind of a smaller hand. So speaking of the child's hand, I will pass it off to Mike now, who's going to talk a little bit about some children that we have recently fit with our hand and a little bit more.
So I want to tell the story about one of our first recipients of the child's hand. His name is Jigme Sherpa, and he's from a very rural and mountainous area of Nepal. This is near the border with Tibet. When Jigme was a few years old, he was playing on the roof of his small house with his brothers, and he fell off and he broke his arm. For many of us, this would just mean a quick trip to the doctors to have the bone set and a cast put on. But unfortunately for Jigme, there was no doctor in the village who was able to help him. This meant that Jigme and his family had to travel to a local village 2 days away to visit a traditional healer and see if they were able to help. The traditional healer told him that he wasn't able to help, and Jigme and his family had to get to Kathmandu immediately to get help. Unfortunately, the only plane that was serving the region that they live in had recently crashed. This meant that Jigme and his family had to walk for a month over mountain passes to get to a road where they could take buses for 2 weeks to finally get to Kathmandu. Unfortunately, by the time they got to Kathmandu, it was much too late, and Jigme had to have his arm amputated. Jigme's family ended up going back to their village, leaving Jigme to stay in Kathmandu to recover and to go to school, and he lived in an orphanage. So the caretakers of Jigme at the orphanage reached out to our partners to see if they were able to help provide Jigme with a prosthetic arm. Fortunately, our partners, who are called Limb Care Nepal, were able to provide Jigme with his own prosthetic arm, and he was the first recipient of the child's hand in the entire world. So we received a message from Jigme's caretaker a few months after he was fit, saying that he's just so much happier after he received the prosthetic hand. He just wants to play around with it, pick things up. Some of the kids used to bully him about his missing limb before he had the prosthetic device, but now they don't, and he's just so much happier. So we first started working on the child's hand due to requests that we got from the public. As Kelly mentioned, there's people that wanted a smaller prosthetic device due to their smaller stature, children or smaller individuals who would fit the arm a lot better. And we're always listening to feedback from patients, from clinicians, anyone around the world, because we're always trying to improve the design, make it more functional, make it more cosmetically appealing, easier to build. And fortunately, we're able to do that thanks to some recent funding that we got from TD Bank Group. So this funding is allowing us to expand to remote and underserved regions of Canada and the US. And this will allow us to provide prosthetics to people in these areas who face barriers to accessing prosthetic care. So something that we learned since we started this project in Canada and the US was that many provinces, each province has their own sort of prosthetic care coverage. So there's some provinces like BC, which will cover 100% of the cost of a device for an amputee every 3 years or so. But then there's some provinces which will only cover 50% of the cost, or some provinces which don't cover the cost at all. And this means that the patient, the amputee, might need to pay completely out of pocket for the device. This can be hundreds or thousands of dollars required. They need to pay out of pocket as well, which can be a huge financial burden. So I think that a lot of people, at least from what we've heard, a lot of people think that amputees in Canada and the US received very cutting edge prosthetic devices, you know, the ones that you see on Discovery Channel. Looks like something Terminator or Luke Skywalker wears. But unfortunately, that's not really the case. You know, those prosthetic devices, the ones that look so advanced, are very expensive. They can be tens of thousands of dollars. And there most likely is not any care coverage for these, meaning that someone would have to pay completely out of pocket for it. In reality, many of the Canadians and Americans will get something called the hook mechanism, which you may have seen. It's a pincer which will open and close. It's made of metal. It's very strong. You can do a lot of things with it, but a number of the users have told us that they find it very unsightly. They also find that it doesn't do everything that they want it to do. So with this funding that we received from TD Bank Group, we're able to start providing these Victoria hand devices to people in Canada and the US who don't have any coverage, or they don't have a device that actually meets all their needs. So we also are developing with the University of Victoria a 3D printed scoliosis brace for these low-income communities as well. So for people who aren't familiar with scoliosis, it's a deformity of the spine. So as a child grows, their spine will begin to curve. And if it gets too severe, you can see that their body begins to bend over. And the only way to really prevent this from the curve from getting worse is through scoliosis bracing and excessive rehabilitation. So the cost of the braces can be very high as well. We received some word from families around Canada who had to pay $4,000 or $5,000 completely out of pocket for a brace. And as the child grows, they need to replace this brace often. So it can be a huge financial burden to the family. So what we want to do is we want to create a low-cost prosthetic brace that can be used in Canada and the US, easily manufactured and low cost. So I've traveled to many of the developing countries where we work, and I've seen many people suffering from conditions that wouldn't really affect many people in high-income countries because they have more access to care. And the only problem is that they just don't have the funds to pay for the care. So there's one of the patients that we recently fit in Kenya. Thank you. His name is Bin Amin. When he was 3 years old, he had an accident and he lost both of his hands and both of his feet. So he had to rely on his mom and others around him for very basic things, getting dressed, feeding himself. But fortunately, when we expanded to a new clinic in Kenya in early 2020, we were able to provide Bin Amin with his own prosthetic arm. So I was fortunate I was there and I saw Bin Amin be fit. And I just remember how happy he was to receive the prosthetic hand. You can see in the photo here, well, I mean the one passed around, that his arm doesn't have harnessing, so it doesn't function. But he was just picking up the hand. He wanted to wear it. He wanted to show his mom that he had a hand again. And it's stories like this that really drive us to continue the innovation on the prosthetic hand technology, to continue to, provide care around the world. We want to drive down the cost of prosthetic and orthotic devices in these low-income communities and the developing countries, because we want to make these devices more accessible to people who are facing barriers to accessing care. As we drive down the costs of the devices, it still might not be affordable to many people, but thanks to help and donations from the public, we're able to provide these people with life-changing devices. Thank you. Sorry, we should have warned you.
I'm sorry, I got trapped in the back. Well, thank you so much for your amazing presentation, and now we are open for questions. Yep, go ahead.
Yeah, you mentioned that there's 20 parts in a hand. Now, can all of those parts be printed on the same printer? And is assembly of the hand a highly skilled job?
Okay, so I'm going to repeat the question just for people who are online, in case they did not hear it. So the question is, can all these 25 parts of the hand be printed on one printer, and is it a skilled job to assemble it together?
Yeah, so all the parts of the hand, well, some of the original hands we made, all the parts were 3D printed, so they all could be done on the same printer. The printers we have, the print beds are kind of restricted in size, so it'll usually take a couple of rounds. Like, we'll print all of the finger parts, and then we'll print the palm, and then we'll print the thumb and all the plates together. But if we have two printers, like we do in some of the clinics too, you could kind of get that both going at once as well, and the limb socket as well, printed on the same printer. In our very latest version of the hand, though, I'm sure you could notice the metal parts on the inside of the finger links. So we just came out with that summer of 2020, and it obviously is not 3D printed because it's metal, but those parts are laser cut. So it was a couple dollars more for a lot more strength. We figured it was really worth it because we really are just trying to make the best hand for the people that are using it. So even though it's a little bit of a mesh between 3D printing and laser cutting technology at this point, it was just a few finger links, and it made the hand a lot stronger. So, and then of course we also use screws and nylock nuts and things like that. But most of the hand is 3D printed on the same machine.
Okay, thank you. Any other questions? Yep, go ahead.
We heard a similar presentation a few years ago, not sure how long ago it was. And at that time, it wasn't used in Canada at all. And nice to hear that that's expanded. But you said 8 countries. There must be many, many countries that really want it.
Okay, the question was that there was a similar presentation on probably hand or upper limb prosthetics a couple of years ago, but this technology was not used in Canada. Now it is. And the question also was about the 8 countries that are probably taking advantage of the Victoria Hand Project, but there must be many, many more in the world.
Yeah, fortunately, well, we had a lot of requests from Canadians. We were helping Canadians before we received the funding, but we didn't really have the funding to do that. We were just kind of finding donations on the side, and we fit 12 Canadians before. But now with this funding, we're able to begin helping more Canadians. And then as for the 8 countries, we're working in Nepal, Cambodia, Guatemala, Ecuador, Haiti, Egypt, Uganda, and Kenya, and 10 if including Canada and the US. But we do receive a lot of requests from around the world. It's very difficult sometimes because there are people emailing us or reaching out to us over social media, and they're saying, I can't get a prosthetic device. I'm living in India or Nigeria. These are places that we commonly have requests from. And unfortunately, since we don't have a clinic there, it's very difficult to get the plaster impression made, what I showed, and have a custom device fit, because we want a trained clinician in the process. We don't want to just have anyone fitting these devices, and that's just for the safety and comfort of the patients. So we are trying to find ways to help more of these people, but we want to help everyone, but we just got to keep growing, and through the years we'll be able to.
Okay, thank you. Another question?
Well, when you talk about a trained clinician, well, what kind of training is necessary, and how much work? How long would it take to train someone and bring them up to speed to do that?
So thank you. The question is on how much training does it take to have this clinician involved in your project?
Yeah, so it's the training's very brief. So the training for the Victoria hand is very brief, sorry. So when we go to the country, we might spend 10 days there. We show how to use the 3D printers, do maintenance, build the hand parts. And it's a few hours a day because they also have all their other tasks that they're helping with. But then as for the clinician receiving the necessary training, it can take 2 years to receive basic training, 4 years for more specialized, and then there's different classifications, and they're called CATs, so CAT 1, CAT 2, CAT 3, and these are internationally recognized. So I know that many of the clinicians that we work with, say in Nepal, there's Amit, who's very specialized, but he had to go to Thailand for training because that's an internationally recognized school. And most countries will have some clinicians with some prosthetists who can fit the device. But we just like to, network with them naturally, have conversations with them. Everyone that we work with is actually mostly from natural connections through friends or friends of friends. And then that's how we actually got in touch with them. And we do receive the requests, as I mentioned, from the patients, but also from clinicians. They say, hey, I'd love to offer this in my clinic. And we like to have conversations with them, make sure they're completely certified, like internationally recognized. And then we just discuss, potentially fundraising to open up the clinic, seeing what we can do to work together.
Yeah, go ahead.
The harness is a critical piece of this. That's, from what I understand, that's how you actually manipulate the hand. So are they pretty reliable, and where do you source those, and can they be easily fixed if something goes wrong? Like, because they're such an important piece of the equation here.
Okay, the question was on the harnesses. How do you manufacture them and fix them, because they're very important for the functionality of the prosthetics?
So we do source the nylon that we use for the strapping here, but the ring that we use here and the part that is together, we actually 3D print using the same machines that we use for the rest of the hand. And they are pretty reliable. I don't know if, Mike, you want to speak more on if you've heard anything of them breaking, but usually, okay, yeah, I've never heard of them breaking, but usually what we'll do is our partners in the country will adjust the strapping so that it fits really well with somebody, just in the little loops there. And then once it's perfectly fit to them, so that just a little shoulder shrug will actuate the hand, we'll usually get a sewing machine and just sew the strapping in place so that it won't move around at all.
Okay. Yes, in the back.
How difficult is it for a child to learn to use it? And are there many that give up after a while, or do they stay with it?
So the question is on how difficult it is for a child to learn how to use this prosthetic arm, and if any children actually give up on it.
For all the users, children and adults or teenagers, it varies. We've seen some people pick it up in a matter of minutes. Some people take a little bit more time. And it somewhat depends on how long they've been missing their limb. Some congenital amputees, people who are born missing a limb, choose not to wear a device because they grew up without a device, or they really learn to live without one, so they choose to not wear a device. But then some people, if they lost their limb 20 years ago, their muscles might have atrophied, they might have lost strength, so it might be a little more difficult for them to learn how to actuate the device. Some children do give up on using the device, but that happens with all prosthetic devices. We've heard of children who have expensive prosthetic devices, and they'll actually break them just because they don't like the look of them. This is something that I heard from Dr. Detchev, who's started the project. When he was doing his research at the University of Toronto, he was asking about the prosthetic hands, and he said that he was told by the prosthetist, well, some kids will just break them because they don't like the look of them. They look too boxy or too unrealistic. So that's why we're also really trying to make the hand look very natural, because we want people to feel very comfortable wearing it. And some people, in North America, the people that we fit, they like the black prosthetic arm, the one that's going around. But in the countries where we work, we paint the prosthetic devices. We want them to look very natural. We want it to look, or the patients also want it to look very natural. And there's also another prosthetic hand type. Sorry, I don't want to reach my limit here. There's another prosthetic hand type, which we didn't mention, which is a completely cosmetic arm. So this was 3D printed on one of our printers, and it's painted. And this is from a company, a US company that we adopted in late 2018. And this can be custom sized to match the person's unaffected limb. So when someone's walking down the street, some people might like to just have this hand poking out of their sleeve. It looks very natural. People won't know that they're missing a limb. As Kelly mentioned, unfortunately, in some of these countries, there's a stigma that's associated with limb loss. So we want to, help people just feel much more comfortable. And this hand, it doesn't function, but some people like that. They don't mind. They just want it to look natural. And I'll pass this one around as well.
Okay, yeah, go ahead.
So it's a mechanical device in order to move the hand and fingers. Have you ever thought about getting into electronic use of brainwaves or anything? Is that the extension of this?
I suspect this might be a little more expensive, but the question is, since this is a mechanical device, have you thought about involving electronics?
Absolutely. So I think for the specific mission that we're trying to fill, we have decided not to pursue electronic routes. Of course, the professor who started the project, he is a microelectronics professor. We definitely could introduce electronics, but it would be expensive, and it's a little tricky too, because if electronics break, we'd have to source materials. It's not really as instantaneous as just being able to print a replacement on a printer. As well, one of kind of the perks of our hands is that you can just wash it. If you're like using it for personal hygiene or something, you can just throw it in the sink and wash it off, whereas electronics, of course, it gets a little trickier. We'd have to make sure it was waterproof. So I think at this time, we've chosen to not pursue the electronics route. But of course, there are a lot of groups out there who are doing the myoelectric arm with the mind control, or the surgeries that can be done to move the nerves down to the end of the residual limb. So there's a lot of cool work being done out there, but it's not the niche that we're filling.
Thank you. Any other questions? Okay, go ahead.
There's some traditional groups like War Amps Canada. How do they fit in with any of this that we're talking about tonight?
How do traditional groups fit in with your work?
Yeah, so we're still learning a lot about such societies and groups across Canada. So we actually talked to someone in, I believe they were in Ontario. We talked to so many people recently, I can't remember exactly where they were. But I believe that they said with war amps, if somebody loses their limb before the age of 18, they'll qualify for life. But then if they lose their limb after 18, they won't. But yeah, there are a lot of groups that are really trying to help provide people with prosthetic devices across Canada. The US, we tried to do some research in, but the healthcare system there, it's a little crazy. So yeah, we've done most of the research in Canada, and there are a lot of groups that are really trying to help people. But there have been people who just contact us directly through our website, and they say, hey, I'd love to try out your arm. I want a lightweight 3D printed arm. It can help with assistive tasks. And then they might also have a device that they get through war amps, like the hook mechanism that I mentioned, or through the government, through healthcare, depending on the province that they're in.
Okay, and Anna, go ahead.
What about the patent? Is this a UVic? Is it? I think my question is, can somebody else just take what you figured out and do it in their locale?
I guess intellectual property question, maybe? Yeah, can anybody take what you are doing and do it elsewhere?
So we do have patents on the prosthetic devices. That's partly because, so we don't want people copying exactly what we're doing, just because we want to make sure that there are trained people in the loop. Like, we want there to be a trained clinician, and the way that we can make sure that this is happening is only working through the prosthetic care providers. There are some people who are trying other things out of their garage, and they're very well-meaning, and we respect them for what they're doing. But at the same time, many of them don't have a clinical background, and they don't know exactly how the limb should fit. There could be pain on the limb. There could be skin breakdown due to rubbing. So we just want to make sure that our devices are only provided through certified care providers.
Thank you. Derek?
Yeah, it's sad to hear that there are some provinces that don't support amputees. But taking one of those provinces and let's say 6, 7-year-old child, by the time they're fully grown, what would it cost to, roughly, to be able to keep up with their growth, providing these same devices?
Oh, so what is the cost to a child to have a prosthetics from, the age she does not have an upper limb to the age when they are full grown?
Yeah, that's a good question. So the cost of the prosthetic devices themselves vary quite a bit. So the cost of the materials of the prosthetic device, say the hook, which I mentioned, could be $500, a little more. And then there's the clinical fees of creating the plaster impression, creating the socket, doing fittings and follow-ups. And that can cost a few $100s more. We've heard around $1,500 per device. And then as a child grows, it will need to be replaced. Mostly the socket. If the terminal device, the hook, is still functioning well, then they can reuse that. But it could be a few $1,000 a year.
Yeah, I was thinking more of your device.
Oh, okay, yeah. Do you want to?
How about your devices? That was actually my question too.
Okay, yeah, sorry. So that's to give a comparison. So our devices, the full-size system is the one that functions, not the cosmetic one there, but the full-size one is around $100 in parts. The child's one is around $70 to $80 in parts, just smaller components, less plastics. And in the developing countries where we work, we're paying the clinicians $80 to $100 to fit the device. And then there's a 3D print group, which also could be the clinicians. So there's a group that we pay to make the device and a group that we pay to fit the device. So we say all in, it's around $300 for a full system. And in comparison to traditional devices, we heard from some clinicians in Uganda when I was there. They said the cost might be 4.5 million Ugandan shillings, which would be around $3,000 or $4,000 for a transradial, which is below elbow device. So it's in cost comparison, it's much more affordable. And since we are a charity, we cover the fees for fitting the device. And this is because many of the people who are missing a limb in these developing countries, it might be very difficult for them to get meaningful work. They might not be able to pay out of pocket. They might need to get help from friends and family. The same people in Uganda, they told us that there's a lot of people who approach the clinic, they get quoted for a device, they get fit, everything, and at the end they get the quote and it's too much and they say, well, I can't afford this, and they just leave and they never get a device. So that what we're really trying to do is make it more accessible to these people.
Just to follow up to that. So taking a child of 5 or 6 or something like that to a fully grown person, how many times would they have to go through this process?
So when a child is 5, how many times do you need to give them a new prosthetics, or at least the sockets?
Yeah, so as I mentioned, the initial cost of the hand, $70 to $80 in materials, then the clinical fees on top of that. And then as the child grows, they might need a socket once a year, and it could be half the clinical cost to fit it. And then the cost of materials for the socket, it's very small. It could only be $20 in materials if the hand's still functional. So we'd say $1,000 less child.
So my question was, how many times would they have to?
Oh, sorry, I keep on forgetting your question.
I know you're not explaining.
Yeah.
But I think he said it once a year, right?
Yeah, around once.
Once a year?
Yeah,
Oh,
sorry.
Okay, so I do have a quick question, also a follow-up on this follow-up. So if the cost of material is $100, is it possible to melt these hands into a fiber again and use them again?
So it is possible to do with this material. We choose not to because of when recycling materials, the strength will go down, and we want to make sure that these devices are very strong. We tell people to use it as an assistive device. So, most people, if they have a hand, they will do 99% of things with their unaffected limb, and then they'll use the Victoria hand for assistive things. They'll use it for, two-handed tasks or certain one-handed tasks when they want to free up their hand. But it shouldn't be that strength bearing, but some people still do. So we want to still make it as strong as possible.
We do give all of our kind of scrap materials or any parts that fail. We do give them. There's a group on campus at the University of Victoria who does recycle the material, though, and they do wind it back into new spools that other hobbyists will buy to use.
So would dirt be a problem as well if they get some dirt into it and then the material will not be as pure?
Yeah, I think that's part of the reason that it's weaker, impurities in it. So as Kelly mentioned, there are people that are recycling it. We just don't have the resources to do that, the machines to do that, and the people to do that. But fortunately, there are groups that will happily take it off our hands.
Literally again.
Yeah.
Thank you. Any other questions?
No,
Yeah.
sorry, one second.
Do you train the clinicians that work in the countries, or does that happen elsewhere? So that's part of your project would be
Is
to
the
train them.
Thank you. Is the training of clinicians a part of your Victoria Hand project, or is it done somewhere else?
So the clinicians are trained at a college. They will get kind of like a degree to be a prosthetist. They'll be a CP, certified prosthetist. But when we do go into the countries, we will train them specifically how to fit our hand in a way. We'll be like, here's how it's a little bit different than a traditional device, and here's how the person will use it. So they do have their actual training, but then we will go and show them the weird specifics that we'll need done for our devices.
Yeah, so in the countries you're not in yet, you need them to have somebody to have that basic training before you can top it up. Yeah.
In the countries that you're trying to get into, you need somebody who will be trained to fit prosthetics.
Yeah. So when we're looking for potential countries, we're hoping to find someone who is a certified prosthetist in the country.
So I have a follow-up questions. Okay, go ahead.
Yeah, it's sort of a follow-up in that sense. Have you partnered then with other NGOs or other groups that provide assistance in various countries? For example, in Kenya, there's a number of groups that work. And I know one in particular that does a lot of work with people who have, physical disabilities and things. Or have there been communication with those groups so you can partner together?
So the question is whether you partnered with other NGOs in these countries to basically get more information from them and be able to help people.
Yeah, we're very happy to partner with these NGOs. We are trying to get into Syria right now to help with the crisis, and we are talking to NGOs there, various sizes, just to sort of provide the facilities, the medical training, the staff, and the people that we're working with in the countries. They're usually prosthetics hospitals that are more set there. And we're very happy to talk to the larger NGOs. It's just that the people we're working with right now are the ones that reached out to us directly. And we're trying to talk to more of these. There is people from one of the doctors groups that was working in the Middle East that was providing those cosmetic arms through someone else prior to us adopting them. But we do want to begin to partner with some of these organizations because they have a footing in the community, and they part of the reason that we're always working with these clinicians in the country is because of their training, but also because they know the language, the customs, the cultures, the community, and they have a stable position there, and they're going to be there for the long term, so they can continue to provide the prosthetic arms, provide repairs. But as we grow, hopefully we can start working with some of the larger NGOs as well.
Okay, thank you. Okay, go ahead, Derek. Last question.
The people that you're working with, you say that they come to you, but is there resistance from the traditional prosthetic providers?
Is there resistance from traditional prosthetic providers?
Because of the cost difference and so on?
Yep.
So there are some people who are against 3D printing in the community as a whole, but then there's a lot of people who are very open to it. And it's one of those things where there's a number of clinicians we're working with, some local. We're very open to 3D printing. They see that the industry is going that way. And there's some people that are more in the traditional sense who they think that 3D printing shouldn't be in the industry. So it's, you know, we've heard from both sides, and we're very happy that there are a lot of clinicians who are very interested in working with us. I mean, as I mentioned, we're working in Canada and the US, and there's a group in Toronto that we were talking to, and they have a bunch of 3D printers in New York, Virginia. There's even the local prosthetists who we know here are getting 3D printers in their workshop, and they're trying it out. And we're very happy to connect with them, to work with them, to provide our hand across Canada and the US. And there's some people that will be resistant to it, but I guess with any new technology, that's how it goes.
Okay, thank you very much. And with this, I would like to thank Kelly and Michael for educating us about 3D printing and about upper limb prosthetics. And if you guys have any spare money at home, you know where to put it. Victoria Hand Project. And yeah, thank you very much. Thanks.
Thank you. Yeah, thank you very much for attending. I mean, we'll still be here for a little bit, and we have all of our props. So if you want to come up and talk to us, feel free to. Thank you.